Hi, I'm Kelly, and this is why you should wear your seatbelt. I've run through on the physics of car safety. We all know some pretty messed up things can happen on the road, from horrible injuries to cars flipping in all different directions. Fortunately, car collisions can be explained and made safer using physics. In Unit 2, we learned about various types of forces and how they impact the way things move. So, when we're in a moving car, what are the forces being acted upon us? When a car is moving forward, the applied force of the engine is greater than the force of friction, which keeps the car moving while the force of gravity and the normal force keeps it on the road. However, when a car collides with an object, all of its force from the engine disperses and the force of the collision pushes the car back into a stop at an incredibly high deceleration. From Newton's first law, we know that an object will not willingly change its motion without an opposing force due to inertia. Taking the average mass and acceleration of a car, you would be slammed by the force of nearly 3,000 newtons, and inertia will cause the motion of your body, which was originally going forward, to be sent flying into your dashboard, since there's no opposing force. So, how do seatbelts protect us? In Unit 3, we explored the law of conservation of energy, which explains how energy can neither be created or destroyed. It can only be transformed into other forms of energy or transferred into different systems. For a car to come to a stop, all of its kinetic energy must be dissipated, either by friction from hitting the brakes or hitting another object. In our case, this means 1,800,000 joules of kinetic energy will transform into heat, sound, and a large part will transfer into the objects of its surrounding and the passengers. However, with a seatbelt and other car safety measures, they help to absorb and disperse the kinetic energy released upon deceleration. A seatbelt holds you in place and stops your movement closer in sync with the car, keeping you from hitting the windshield or dashboard. With the seatbelt, your stopping distance and the impact force you experience is 4 to 5 times less. In Unit 1, we learned how to understand the characteristics of motion through a distance-time graph. The passenger's stopping distance with a seatbelt is much lower compared to the absence of one, drastically lowering the chances of serious injury. Seatbelt safety matters. But what can be done to lessen the force of impact, increase acceleration time, and therefore decrease chances of an injury in an unavoidable collision? From what we know about force, the greater mass an object has, the more momentum and energy it carries. So, in a collision, the object with less mass will take the brunt of the blow. You can reduce the forces on you and your car during an unavoidable crash if you are able to redirect your path towards lighter objects that will increase your deceleration period, like a bush rather than something heavy with firm standing ground.